Computer models of Earth's atmosphere can tell us a lot. Trained on how the atmosphere typically operates, the models take in data about temperature, wind speed, humidity, and more to give us important insights into the world around us. Computer models like NASA's GEOS model can help us study how chemicals move through the atmosphere, how the oceans circulate, and where air quality might be affected by fires and pollution. These models can also provide a look at what might have been if circumstances were different. For instance, climate models can forecast how temperatures might change with different levels of carbon emissions. In 2020, the world threw the models a new test when people began behaving very, very differently with almost no warning. A global pandemic set in. Around the globe, people stopped driving and flying in large numbers, started staying home, and completely changed their pollution patterns. In particular, emissions of nitrogen dioxide, a common air pollutant released by cars, airplanes, and many factories, declined significantly. But just how much did the shutdown change our emissions? NASA's GEOS atmospheric composition model offers an answer. The model run functions by assuming that nothing was different in 2020, that people continued behaving roughly the same as they would have with no activity shutdowns, adding the same number of atmospheric pollutants to the air. It's then a matter of subtraction. Comparing those models to real-world observations made by satellites during the shutdowns shows how significant the decrease in pollution was in various cities. Activity shutdowns started in Wuhan, China, and in January, observed emissions of nitrogen dioxide began to diverge from what models predicted, about 60% less than predicted, that is. As the virus and the associated shutdowns moved west, European cities began to experience decreased levels of nitrogen dioxide emissions as well. In Madrid, Spain, nitrogen dioxide emissions were also 60% less than modeled. Shortly after, cities in the United States began to follow suit. In March, New York City shut down all but essential activities, and emissions dropped by 45%. 50 of the 61 analyzed cities show nitrogen dioxide reductions between 20 and 50%, clearly linking lower NO2 emissions to pandemic-related restrictions, and therefore human activity. This sudden change in human behavior gives us new insights into the relationship between human activities and air pollution, which still has many unanswered scientific questions. The only way we can fully understand air pollution is by combining surface observations, satellite data, and computer models. With NASA's satellite monitoring system and computing capabilities, it's uniquely positioned to provide detailed information about air quality everywhere in the world.